Now the first big question that first came in, right? Is this all LLM or this is all ML? And the real answer is use the right tool for the right job, right? And what you see here on the left-hand side, this is where we are ingesting lots of raw data, whether it's metrics, whether it's events, whether it's syslogs, stuff like that. And that is, we are using ML techniques to figure out exactly what is happening, right? So there is no generative part on this side, right? Why? About the accuracy, right? There is no hallucination on this side. This is all well understood math, right? I mean, even this is understood math, but this is all math like the regressions and clustering and cosine similarities and stuff like that, right? Because we are getting all this data, analyzing it, and putting together things without generating anything. Okay? Now, when do we start to use the generative AI? Is really to offer that easy experience for an operator, right? So rather than somebody typing a query saying /select, choose this table, and show me the interface errors, right? A lot of those graphs are accurate representation of the data that exists because there is a query that happens. But translation from that English language to query is a job of generative AI. Or once you get an output, you get a JSON output, translating that into an English language is the job of generative AI, right? And that's a very important part, right? We are using generative AI as a combinatorial tools, not a replacement, right? And again, right, as these technologies evolve, we will basically evolve with whatever is best outcome. Right, so again, this is where there is no hallucination.
There's a question.
The portion you're showing, three different potential services that have models. Are you leveraging all of those services, or do you have your own internal service?
Yeah, so like you can use whatever service that is allowed by your corporation, right? So internally, we can even use Llama 3, right? So that is, again, I'll go into the details. It's an API call. So it can be replaced with whatever engine that is allowed in your organization.
Okay.
Yeah.
So I was going to say, you talked about the evolution. So I assume that ML was built into this before Gen AI came out, before ChatGPT. So as you evolved, now you've got Copilot, you've got Gemini, and you've got ChatGPT. I assume this is just
those are just representative.
Right.
You can use DeepSeek if you want. Right?
And
you can use whatever you want.
When did you put AI at the end of your name? I'm just trying to figure out the path.
The starting of the company was based on AI, right? Because
ML, right?
Sure, yeah.
Because I mean, I'm trying to figure out which one. You don't want to get people confused. You're saying that we've been legitimate AI in the form of ML. We're not just Johnny come lately to this. We've been doing this for real.
Correct. And again, so now we'll go into the actual details of the data flow, right? Because that's super important. So again, right, we talked about, hey, how do we collect data, right? So this is basically a distributed process. So some of your data is going to come from these remote engines, which is your on-prem stuff, understands SNMPs and Kafkas and all that. Some of this data is going to come from your cloud, and this is where using ServiceNow and PagerDuty, and these are where we are logging tickets. Okay? So this particular part, each of these collecting devices are also based on Kubernetes. So they are horizontally scalable. And I also answered the question earlier, even the top cloud is based on Kubernetes, horizontally scalable, right? So that takes care of the volume and the velocity part of the data. Another big problem is the variety. How do we solve for variety? Over the last 5 years, we have built a whole lot of connectors off the box, right? So there was a question about, hey, SNMP, GNMI, and gRPC, right? SNMP also has like a bunch of vendor-specific MIPS, standard MIPS, right? Then there are event stuff like Kafkas and RabbitMQs. There are standard like the data stores like your Prometheus and Splunk and all that, right? So these are all over the 5 years of existence already built in. But what is more critical is how we make this easy to extend. So the one realization is there is no universal standard telemetry format. So we built a declarative ETL and we built a compiler, right, to understand your schema and write code to write the parser to understand your schema. Right? So if you bring me into a new environment and suddenly there is a different type of data source, we can ingest that data source using this compiler in a matter of days. All we have to understand is what the syntax is, and the declarative ETL makes sure that the data goes into the system in the standard format, and if you want to invent a new type, we will do it. Right? Very, very flexible. Right? The fundamental thing is we do not assume anything. We are built with flexibility.
We could stop right there for 5 hours. This is fantastic.
So I think in this one, I think there was a question before also. I would say I can challenge anyone to give us a type of data source that we cannot ingest, because so far we have seen that we have ingested like legacy network devices, different kinds of, even things like folks have their own CSV files with different kind of data schema. So I would say any data we throw at us, we will take it. That confidently I can say that, like 100%.
Has anybody heard of TL1? Right. So TL1, when I started working, TL1 was an old protocol. Right. So and it tells you how old that is. But we support that because a customer wanted it. Hey, it's a schema. Like the compiler builds the parser, we can start to ingest it.
Yeah, well, so there's two things. One is, of course, the data that you're getting, and there's also the way in which you're getting the data. So leveraging things like OTel and eBGP, where you can get really low overhead but high, detail. And of course, the forever battle between SNMP and GNMI, like, we hope that the world would get to GNMI faster, but it took a long time.
SNMP, GNMI, those are obvious ones, right? But even like RIB, even like BMP, right? I mean, these are our data sources, right? I mean, that's the real-time routing data, right? Real-time data from like your cloud providers.
Is there any way for us to gather, like, are you tapping also into like the backend providers? So if I'm connecting to Azure through Verizon, where you can actually see like not just my AS boundary, but the actual, because otherwise it's a black box from AS to AS until I get to the provider. And I know that's always a tough gap to cross.
See, again, right, whatever you can see and you can provide me the data, we can take it. Right? But this is where in the example that I showed, that Verizon or AT&T was a black box, right? And so there we figured out there was something wrong, either based on interface gaps, which I understand, or even the latencies which are going over the system, right? So like whatever data you can give, we can handle it.
Right.
So now we talked about a lot about data, right? But data makes sense only in the form of context, right? So what does the context gives you, right? So the context gives you, hey, what does this even mean, right? So what is the inventory? What is the configuration? What is the location, right? What is, so like a real example, when Hurricane Helene came in, one of our customers wanted to essentially prepare for that thing. And they said, you know what, tell me all my data centers where Hurricane Helene is going to pass through. And so we just ingested that data from the weather channel, right? And we know the lat long. We ingested the data from weather channel. We could tell the customer that, hey, these are the properties that you should be watching out for. Right? And we are taking this data from everywhere, Netbox and ServiceNow, and even as Deva said, hey, if you don't have anything, we'll take your CSV file. And then in addition to everything, the metadata makes it easy for people to interact with it, right? So there is a circuit ID, there is an interface name. That does not mean anything to an end user. So when you are giving that conversational interface, hey, the connection to Verizon in San Diego makes a sense, and not that particular what that IP address is or what that interface name is. So I'm going a little bit faster because this is really the money slide, if you will, and that gives you the accuracy of the data and how we process it. So the data we talked about, hey, it's coming from all these different places. It got a lot of context with CMDB and metadata. So this is the first time all data from all different silos come together in one place. Right? And so this is where we really start to get to work. Right? So far it was all about data ingestion. This data flow is where we get to work. What is the first thing we do? Right? The metrics are a bunch of numbers. Right? So 25% CPU utilization, 23%, 29%, just the numbers. They become interesting when suddenly whatever is 25 to 30% becomes an 80%. That's an event. That is something interesting that you need to understand. Right? So we baseline these numbers to understand what is normal and what is not normal. And we do this for every metric we get. Like the millions of metrics, baseline, number one, so that we immediately know what is not normal. Similarly, the other big concept is log mining. What is log? Log is a fragmented English statement written by the developers for their own use. What do they have? They have IP addresses, they have process names, they have interface names. Right? They have a bunch of things that only a developer understands. Right? And so nobody can really use that to, nobody can even parse it. So this is where we start to use another machine learning stuff called named entity recognition. Right? Once you feed system thousands of logs, it knows what all different types of IP addresses are, or what all different types of interface names are. Right? So now you got the named entity recognition. Then you run other algorithms like clustering algorithms. Right? So using clustering algorithms, you know what logs kind of behave together and what causes an event. And that is all enriched with the metadata. Right? So at the end of these two big processes, and again, right, these processes are not generative. These processes are working on real data to find real correlations. Okay, that's an important part, accuracy.
You mentioned normal, which is always one of the hardest words to use when we describe this. Is it normal in the sense of like 95th percentile, 99th percentile? Is it relative to like, hey, it's bad, but it's okay to be bad?
That's the slider we even showed you.
Right.
Right. So you can decide what percentile you want. So this is again, right? Once you do these big operations like key operations, log mining and baselining, you start to generate those smart events. As you can see, a lot of these events, the blue ones are perfectly fine events, right? There's nothing to worry about. They are okay events. But then these are the anomalies. The red ones are the anomalies. This is what we do by using. First step is temporal, like look at a particular period of data, and this period of data is configurable. But particular period of data where you say, you know what, hey, these are all the anomalies that I saw. Okay. In the previous example, the VM and the link down, it's likely it happened in the same 10 minutes. Right? How do I know they are different? So this is where we do another actual statistical machine learning technique called all your cosine similarities and clustering, right? And so with those algorithms, we figure out what are these correlations. A lot of times the first correlations are undirected. Based on, again, right, this event depends on this event. And once you learn the patterns, you can even find the causality.
On this, do you have a chance to actually tell it to stop watching things like so many do with like zero events, planned maintenance, like, and also even when there's live and there's some network outage, how do you deal with zero data that's feeding in but not affecting the inference?
The beauty is we can even we can process an email that is coming from your provider saying there is going to be a maintenance outage, and in that time we suppress those alerts. So we do not produce fault alerts where somebody is actually doing maintenance. Right? We do that.
Excellent.
And then it goes to the correlation. Right? A little bit thing about event correlation, right? This is pretty standard stuff. In the interest of time, this is exactly what, say, a Netflix or what your Instagram works, right? Every event has a bunch of properties which are annotated and all that, and any event that has more properties together is strongly correlated, and any event that has less properties together is weakly correlated. And to answer your question, based on the confidence interval that you want and based on the type of correlations you want, there is actually a slider which allows you to see different types of events.
And then the manual context, and like you could basically give it a sort of a Bayesian push towards a potential thing that will then be defined. Where's the data stored about the customer specific enrichment?
All this data is stored in either MongoDB or Prometheus. And again, in terms of where it is stored, it's a single tenant system. The data is stored wherever that, it could be on-prem, or it could be in your cloud instance, or it could be in our cloud instance.
Nice.
And this is a single tenant, so this is your data, nobody else sees it.
Fantastic, thank you.
Now, again, right, the big question in the room, where is ML and where is AI? So this, again, right, we are worried, like, this is AIOps. This has to be accurate. So this, everything that you see is that ML part, which gives you the output, which is a smart engineer can generate. So this is a human level intelligence generated from raw data using these machine learning algorithms. Now, how do we make it easy for people to work with the system? This is where that generative AI comes in, right? Some of that you already saw, that hey, the root cause analysis, right? Like changing the DNS. A lot of that is not coming from this correlation. That is coming from the other places. On top of it, like now you take any base LLM which understands English, we add our specific query language details on that, that's the blue circle, that translates that English sentence into a query to make it sure it's accurate. And then the last circle that you see is your specific data. So the black box could be any engine that you want, right? It's like it could be any LLM that is approved for you to use. On top of it, we come up with a blue circle, which is fine-tuned for our application, the networking application. And then the red circle that you're seeing is your actual locations, it's your actual IP addresses, and learning about your system.
So let's say I'm taking a base model, right? Whether it's GPT-4, whether it's Llama, whatever. What I'm doing with this essentially is all my data is being collected. On the back end, you're creating a RAG or fine tuning for forecasting or whatever you're doing, and then that data is coming out in real time, right? But I'm sorry, I keep getting hung up on this real time thing, because ingesting data, creating a RAG around that data, depending on where that's all taking place, it takes a little bit of time. Fine tuning takes even longer. That's why it's typically used for forecasting. But I think I'm just getting hung up on the real time thing.
Sure, let me show you this, right? This data and the blue circle happens in our systems. It's not for the inference time, right? So the fine tuning does not happen in your network to begin with. Only that final red part, which is about your data, that's learning your IP addresses and your systems, right? So that would happen in first few hours of the deployment, right? And that's a very thin layer, right? The English and the selector language already understands the notion of an IP address. All we need to understand, what is your IP address? That's a very thin layer.
But it would differ based on the base model that you're using.
No, let me. Yeah, we can table it, but this is an important part.
Yeah.
So what this here is doing you asked me the question in this plain English. Right? I found, based on LLM, 3 entities here, right? There is a circuit. It could be a port, it could be an interface, it could be a circuit. You know, this is an error, IF error table we need to look at, right? And I know where the condition where I'm looking at is not in Chicago, not in Denver, but in San Diego. So that becomes a specific query into our database, and that runs through this SQL and provides that answer. Okay, so this part of LLM is English translation, is not generating data. And again, right, this is where this could be real time because this is doing very little work. It's just doing the entity recognition.
It's always tricky because real time, especially when we think of databases, we think of like sub-second response as real time, and it's tricky. I know real time's as a good marketing term, and it's you get run over the coals every time about it. One other question about dynamic changes. So an application, we'll call it Sunrise. It's a containerized application, 7 pods, whole lot of craziness going on, lots of containers, but it's constantly rebuilding itself, right? We're doing fresh deploys every 3 days. I want to monitor the application, but all of the entities underneath it are constantly getting swapped out. How do you track in the DVR format that, you know, the pod may be the same label, but everything underneath it is completely different every 3 days? And how do you maintain that along with the correlation?
So can we take that?
Absolutely, yeah.
Already,
it's a tough one.
No, I'll take that answer. Like again, right, it's just a matter of going with the last slide. And again, right, so now talking about the real time, right? The system figured out all these correlations. It found a JSON format. We have already trained our systems to understand the ML. And now it is also fine-tuned with understanding your IP addresses and your locations and your VMs. So now we again invoke LLM to convert that into a human readable format. Right? So it is an inference level interaction. The training is not happening, at least the LLM training is not happening on a every day basis. It's lightweight understanding the entities when the question is coming from English to the query, and once the response comes back, understanding the JSON and converting into an human readable English, that's where the LLM is.
An odd question, maybe. I have my ops team are in Brazil. Can they speak to it in Portuguese?
Yes.
Right. So that we do naturally always move towards English. It's a North American, you know, arrogance, but obviously I want to make sure that the rest of the world is represented.
Yes. Again, right, we showed in one of the customers, they wanted to say, hey, talk to me in the pirate language. And it started to talk in pirate language. Right? So those are the properties of the LLM. Right? The core platform is in English. Okay. So this was the main last slide, and again, hopefully it answered all the questions. And because again, right, the LLM is doing relatively small work, it's really real time as you saw in the demo. So again, right, this is a summary. This is a cloud native platform meant for the infrastructure and network operations. So we are using AI or ML as a horizontal technology, but with our expertise, we are focusing on these 2 verticals and providing you the accurate results. Right? So
I think
just stop at that.
Just to close it, the last point is the most important one. So our product comes with where we help the customer build the solution. It's not that we just sell the product and we don't touch it. We onboard the platform, we maintain the platform, and we stay with the complete life cycle of the platform. That's the key difference for which we are winning a lot of business.